Hey everybody. So today we're going to get into 8.6 using cube roots and fractional exponents. So the first thing you might notice is we're skipping past 8.5, so that's fine. But yeah, today's all about what do we do when we have something that's considered a cube root? Okay, and then eventually what happens when we have exponents that are fractions? All right, so two kind of new things, but they actually relate to one another very tightly. Okay, so first things first, go ahead and get the title and get this first example here, and we'll kind of compare the square root of 8 to the cube root of 8. Okay, so what's the difference between these two? Well, here's maybe the first thing to point out. When we have square roots, technically, there's always been an invisible 2 right here. All right. And normally this is not written because it's implied. But if you guys remember, when we look for, when we break down a number in square roots, we're always looking for pairs 2 of the same number. And that's actually what this represents. All right. When we go to do a cube root, all right, when we break the number down, we're going to break it down like we always would. But instead of looking for pairs of numbers, 2 of the same numbers, we're going to be looking for 3 of the same numbers. And really, that's the only difference between square roots and cube roots. Okay, so let's do it on these real quick and kind of compare them. So if I were to break down 8, I would think, okay, 2 times 4, 2 is prime, 4 can be broken down into 2 times 2. Let's cross it out. Okay, so yeah, we broke it all, into our prime numbers. And for a square root, again, like we've always done, we'll be looking for 2 of the same number. Pairs of numbers is how I, say it. So there's a pair of 2s. This 2, though, would not pair up. It would stay inside the radical. Okay, so the square root of 8 would be a 2 square root of 2. Okay, when we go to do the cube root of 8, again, we would break it down the same way. We're still looking for 2 numbers that multiply to get 8. So I'm thinking, okay, 2 times 4, 4 breaks down into 2 times 2. All right, so just like this. But now when we go to look for our numbers, like I mentioned, we are now looking for 3 of the same number. All right, and so on this one, it looks like, yes, we do have 3 2s. And what I like to do is, just like before, I like to circle all of them. All right, and that I guess trio, or however you want to call it, this group of 2s means a single 2 comes out of our radical. All right, what's not grouped up, or I guess we'll use the word group now. What's not grouped up would stay inside the radical. On this thing, everything is grouped up, so the radical disappears. Okay, so that is the fundamental difference between a square root and a cube root. And you guys will see the fact that there's a 2 in front of a square root and a 3 in front of a cube root is going to come back when we get into the looking at fractional exponents. But for now, let's just practice dealing with cube roots. Okay. Okay, so go ahead and get this one. We'll do the cube root of 27. Okay, so again, right now, we're not really worried about whether this is a square root or a cube root. We're just worried about breaking this thing down into prime numbers. Okay, so 2 numbers that multiply to get 27. I'm thinking 3 times 9. Okay, 3 is prime, 9 isn't. 9 breaks down into 3 times 3, cross it out. Okay, now we have a bunch of prime numbers. Since it's a cube root, we're looking for 3 of the same numbers. And yeah, we have 3 3s here. So those can be grouped together. Okay, but just so happens there's nothing else that doesn't group up. And so this thing turns into just a nice clean 3. Okay, so the cube root of 27 is 3. Okay, so I guess we would consider that actually a perfect cube. Okay, just by the way. Okay, so let's look at a problem that has us subtracting a square root and a cube root. Okay, go ahead and get this. Okay, well, if you guys remember, to be able to add and subtract numbers, they had to be attached to the same exponent. So let's break these down and let's kind of see what happens on this problem. All right, so the square root of 49, okay, we know 49, 7 times 7 gets us a 49. 7s are prime, so we're good to go here. And by the way, these are separate from one another. So, I can't combine these numbers with this one. They're not being multiplied, right? If they were, I could, but they're being subtracted. So anyway, the square root of 49 looks like we have a pair of 7s, and it looks like, yeah, it's 7. Okay, and something, you don't need to, but just remember, technically there is a 2 right here. All right, I just want you to kind of start thinking of it that way, even though it's not written there. Okay, On this one, the cube root of 8, let's go ahead and break it down, which, by the way, we already kind of did this, but let's do it again just for the sake of our notes. I know 2 times 4, 4 breaks down to 2 times 2. Okay, so since it's a cube root, we're looking for 3 of the same numbers. We have 3 2's there, nothing left inside the radical. So the cube root of 8 would be 2. All right, and they're being subtracted. We completely eliminated the radicals, so we can actually, do this final math. 7 minus 2 is 5. Okay, so just kind of interesting. The square root of 49 minus the cube root of 8 is 5. All right, so sometimes, your problems work out that clean. That's what's kind of fun about these. Okay, so I'm gonna have you guys go ahead and try a couple of these on your own. Okay, go ahead and break down the cube root of 125, and then break down the cube root of 64 and the square root of 64, and see what happens on these. Okay, try them out. Okay, so on this one, cube root of 125, again, I'm not worried about the cube yet. I just want to break down 125, and I'm thinking, okay, I know that 5 would divide into 125, so 5 times 25 is going to give me 125. 5 is prime, 25 can be broken down into 5 times 5, cross it out. All right, and it looks like we have, again, we're looking for 3 of the same numbers. We have a group of 5's, which means a 5 is going to come out of our radical. Nothing left inside. You guys can see we're dealing with a lot of perfect cubes where we're kind of eliminating the radical sign. Everything is coming out of it. Okay, and there it is. Okay, on letter B, the cube root of 64 and the square root of 64. All right. I might want to make a point on when we get to this one. Let's go ahead and let's break down the cube root of 64. Okay, so 64. When I think of 64, I think of 8 times 8. All right, that's the first thing that comes to mind for me. So that's what I'm going to start with. All right, 8. I can break it down into a 2 times 4. Cross it out. Same thing here. Break this down into a 2 times 4. Cross it out. These 4's can be broken down into 2 times 2. Cross them out. Same thing right here. Cross them out. Okay, this is a problem where crossing out these numbers we broke down is very, very important. It'd be really easy to mess this up. Okay, but now we have a bunch of 2's here. We're looking for 3 of the same number. Okay, so I notice I have 3 2's here, and I also have a group of 2's here. Okay, this means a 2 is going to come out. This means another 2 is going to come out. Okay, and then they're being multiplied. So ultimately, let's finish this one real quick. 2 times 2, we're getting a 4. So the cube root of 64 is 4. Okay, let's take a look at the square root of 64. All right, here's a point I want to make. The square root of 64, I broke this down into an 8 times 8, right? Okay, and I could continue to break this down, and I would, break it down into 6 2's, all right? But here's something I want you to realize. We're always looking for pairs of numbers. If I already have a pair of numbers, like 2 8's, I can just stop. And I can say, oh, okay, sweet, I have 2 8's. I have a pair of numbers that are going to come out of the radical, all right? This pair of 8's means an 8 comes out of a square root. All right, and that's it. The square root of 64 is 8, right? Like that's one of them you might have memorized. I just want to point out, if we had broken this down into the 6 2's, just imagine we had these 6 2's. I would have said, okay, I have a pair of 2's, another pair of 2's, and another pair of 2's. 2 times 2 times 2 would have got me 8. Okay, I would get the same answer. It's just a longer way of doing it. Okay, so what I want you to realize is on square roots, if you can just start by thinking, oh, these 2 numbers multiply together, you can stop, even if those numbers can be broken down. Okay, so yeah, it looks like we have a last thing, these are being added together, so we have ultimately a 4 plus 8, so it looks like we're getting 12. Okay, so yeah, some good stuff here, but don't overcomplicate it. Cube roots, you're just looking for 3 of the same number. That's it. Okay, so here's the next thing. This is going to kind of lead us into dealing with fractions, or fractions as exponents. So go ahead, get this slide here, and we'll make some sense out of it. Okay, so what this says, there are technically 2 ways to write square roots and cube roots. All right, and really any radical, but we're focusing on square roots and cube roots. Okay, here are the 2 ways. We can write them using a radical sign like we're used to seeing, or we can also write them using exponents. All right, and here's the big point I want to make. these two things, maybe let me bring this up a little bit. Okay, these two things, the square root of 8 and 8 to the power of 1/2 are the same thing. They're the same number. All right, they represent the same thing. All right, and here's what I want you to maybe realize. And if you have colored pencils or markers, let's kind of highlight these numbers. Okay, let's say this one is green and this 2 is red. Okay, here's the reason why we're going to do this. The denominator of a fraction represents the number in front of your radical. Okay, this 2 is telling me this is the square root of this number. Okay, the number on top is whatever your number is taken to the power of. Okay, that kind of said that oddly, but this 1 is telling me that this 8 is being taken to the power of 1. Okay, so that's why these are the same thing. Okay, but that's the big thing to take away from this. This denominator is what your radical is. You know, this is a square root because there's a 2 on the bottom. This top number is whatever your number here is being taken to the power of. Okay, so really kind of important slide. If you don't have colors, man, maybe like darken the 2 and really make it obvious that those are the same thing. Okay. All right, cool. So now that we know this, let's make some sense out of it. Okay, let's do the 16 to the power of 1/2. Go ahead and copy this. Okay, to be able to solve this, I want to rewrite this as a radical. If we ever see a number taken to the power of a fraction, we're going to turn it into a radical. All right, so let's go ahead and let's do it. Let's turn this thing into a radical. So 16, here's what we know. This 2 on the bottom means this thing is a square root. All right, and by the way, let's just put the 2 there just to kind of show ourselves. Okay, there's the 2. This 1 on the top means our 16 is taken to the power of 1. Okay, so this is technically what this represents. Let's go one more step and actually just show us this is the same thing as just the square root of 16. Okay, this 2 is invisible, and also this power of 1 is invisible. All right, and we know the square root of 16. We could break it down, but this is a perfect square. 4 times 4 gives me 16, right? So I know my answer is going to be 4. Okay, and if you didn't know that, by the way, you could show yourself in your notes 4 times 4. We could break these down even more if you guys remember, but we have a pair of numbers. That pair of numbers means a 4 comes out. Okay, but really this right here is what I want you to wrap your head around. Okay, 2 on the bottom meant we had the square root. 1 on the top meant it was to the power of 1. Okay. All right, let's try another one of these that's similar, but we have this, this negative here. Copy this. Okay, so first thing, the negative throws a little bit of a wrench into this thing, but that's okay. Let's point out what's going on here. First of all, if you guys remember, negative exponents, we cannot have them. All right, but to get rid of them, all we need to do if this thing's up in the numerator is send it down to the denominator. Okay, so this is going to turn into a to the power of positive 1/3. Okay, and then there's a 1 on top. Okay, so that's just a little reminder. If there's negatives, we got to either move it down or up depending on where it starts. Okay, but now down here, let's rewrite this. I know that 8 to the power of 1/3, this 3 means that we have a 3 in front of our radical. Okay, this is a cubed root. Okay, the 1 on top means the 8 is being taken to the power of 1. All right, and then up here, we have that 1 still there. Okay, remember 8 to the power 1, it's just 8. Don't let that throw you off. So right now we have the cube root of 8. Okay, and if you guys remember, we've solved the cube root of 8 twice on this already. Let me point out, cube root of 8, we did it here, it was 2. And then we also did on the very first slide, the cube root of 8 was 2 here. So what I'm trying to just say is we could break this down and look for 3 of the same numbers, but we've already done this. We've kind of memorized the cube root of 8 is 2. All right, but if you want to show yourself in your notes, 2 times 4, 2 times 2, and then this group of 2s means a 2 comes out. It's not a bad idea, but I just want to say if you memorize some of these, more power to you. Okay, so there's our answer, 1/2. Okay, and that's kind of interesting. Think like 8 to the power of negative 1/3 equals 1/2. That's like, you wouldn't expect to get such a simple answer out of this, but yeah, it happened. All right, so our next problem is going to be comparing what do we do when we have 9 to the power of 1/2 compared to 9 to the power of 3/2. Okay, go ahead and copy this and we'll get into it. Okay, so first thing, 9 to the power of 1/2, we know what we're doing on this. That means that 9, if we have our radical, that means there's a 2 in front of the radical, and it's being taken to the power of 1. All right, so this is really just the square root of 9, okay, which you probably memorized is 3. Okay, using the same logic, let's go ahead and break this thing down. So again, I've got my 9. Maybe this is the best way to do it. Write the number first, put the radical symbol. What's in the denominator goes in front. What's in the numerator is what your number is being taken to the power of. Okay, so this is really the square root of 9 to the power of 3. Okay, so what do we do with this? Well, 9 to the power of 3 is 9 times 9 times 9, right? So if I wanted to break this thing down, I could break it down into just that, 9 times 9 times 9. Okay, and then from here, I can start potentially just looking for pairs of numbers. Remember, we could break these 9s all down, but I notice I have a pair of 9s right here. Let's go ahead and circle. Okay, but this 9 doesn't pair up. The question is can it be broken down any farther though? Yeah, a 9 can be broken down to a 3 times 3, right? Cross it out. Okay, so it actually looks like we have another pair of numbers. A 3 is coming out of this thing. Okay, so, and it looks like nothing's left over. So we're getting 9 times 3. So it looks like ultimately this one is going to be a 27. Okay, so what I want you to just realize, do not be afraid of this. This number is the type of radical you have. This number is what it's being taken to the power of. All right, and by the way, that might be something worth putting in your notes, what I just said. Okay, so let's add that to this. Let's say type of radical. So type of radical, and then taken to the power of 2, or taken to the power of. I guess if that makes sense. Taken to the power of. All right, if you want to add that to your notes, I think that's just a good way to remind yourself, okay, that's the type of radical, it's square root, taken to the power of 1. Okay, so let's keep going. I know we have kind of a lot of these, but I really wanted to focus in on it. So let's try this example here, and then I think we just have one more problem. Okay, so 125 to the power of 1/3 versus 125 to the power of 2/3. All right, let's try it out. So first things first, I know on this one, this means I have 125. My radical, that 3 means this thing's a cube root, and it's being taken to the power of 1. Okay, so let's go ahead and break this thing down. 125, I think we've done this a little bit, but we know that a 5 goes into 125, and it goes into it 25 times. So we can break this thing down into a 5 times 25. Okay, remember, just use a calculator, plug in some, or divide it by numbers it'll be divisible by. 5 is prime, 25 isn't, breaks down into a 5 times 5. Okay, and again, since it's a cube root, I'm looking for 3 of the same numbers, and I got 3 5s. Okay, so that means a 5 comes out. Okay, so 125 to the power of 1/3 is 5. Let's take a look at this one. 125 to the power of 2/3. Okay, well, 125, we know our radical, the denominator means it's, again, a cube root, but this 2 means it's to the power of 2. Okay, so, what do we do here? Well, remember, 125 to the power of 2 is 125 times 125. Okay, and we can write it just like that. 125 times 125. All right, and from here, I'm thinking, oh, can I circle these pair of numbers? No, I can't. This is only, I'm looking for 3 of the same number. I only have 2 of them, so I need to continue to break these down. All right, so we already did it here, so let's do it real quick. I know 125 is 5 times 25, cross it out. 25 is 5 times 5, cross it out. Same thing here. Okay, now I can start to look for 3 of the same numbers. It looks like I have a group of 3 5s here and a group of 3 5s here. right? Nothing else left over, which is kind of a theme of this particular lesson, okay? But it looks like this means 2 5s are coming out. So 5 times 5 gives me a 25. Okay, so maybe something to just kind of realize here. These were basically the same problems, but this one was to the power of 1, and this one was to the power of 2. And yeah, 5 to the power of 2 would give me 25. I don't know if there's a whole lot of connection to make there, but it's something to kind of pay attention to. Okay, so last one. I want you guys to go ahead and try one on your own. Take 16 to the power of 3 halves, okay? Go ahead and write out the radical, and then break it down and see what happens. Okay, so I got a 16. Okay, here's my radical sign. What's in the denominator goes in front. This is to the, this is a square root. That 3 means my 16 is to the power of 3. Okay, if you got those mixed up, be really careful. Okay, from here, let's break it down. Here's the thing, 16 to the power of 3 is 16 times 16 times 16. Okay, might as well start with that. All right, I'm looking for pairs of numbers, right? Well, there's a pair of numbers right there, pair of 16. Okay. This 16 doesn't pair up, but we can continue to break this one down, right? So I'm thinking 4 times 4, all right? Oh, look, we have another pair of numbers. I could continue to break these down, but I just noticed, oh, pair of 4s, sweet. Let's circle it. Okay, so there it is. Everything pairs up on this. This means a 16 comes out, and this means a 4 comes out, all right? So last thing, 16 times 4 gives me 64. There we go. All right, so that is how these problems are done. I hope you feel a little bit more comfortable. Running into this before you did this lesson maybe would have been a little tricky, but now you understand, okay, this is just a square root. This number's being taken to the power of 3, not too bad. All right, guys, so I'll see you.